All right, Chem, today I'm going to teach you a little bit about these polyatomic ions that we've been learning about. So poly means many, atoms working together as an ion. So if you look at the screen, you're going to recognize that this is the non-metals part of the periodic table of the elements. So get your periodic table of the elements out, and then note that we've got boron through fluorine, and then fluorine down to iodine. Now, I've left the noble gases out of this particular section because the noble gases don't bond, don't form polyatomic ions. So we're going to go over some patterns on the polyatomic ions, patterns of polyatomic ions on the periodic table of the elements to save you from memorizing all of these polyatomic ions. At your level in chemistry, you will have the list of polyatomic ions to refer to. But in the future, if you decide to study chemistry in college, you will be expected to know these. So let's go over the patterns on the charts. So we've looked at our periodic table of the elements, and we've recognized how it matches up to the screen that I'm sharing with you. So the outies are the outside guys on the periodic table of the elements. So it's boron, carbon, nitrogen, chlorine, bromine, iodine. So those are the outside of the nonmetals once we're ignoring the noble gases. So oxygen and fluorine are two electronegative. They don't play in this polyatomic ion game because it takes a lot of sharing to play in the polyatomic ion game. So the outside ATE versions of polyatomic ions have 3 oxygens. The inside ATE versions of polyatomic ions have 4 oxygens. The ATE version is the most common form of a polyatomic ion, and we'll see how the other polyatomic ions are related to. So notice the charges march inward. So fluorine and oxygen don't play this game, and then nitrogen 1, carbon 2, boron 3. Chlorine 1, sulfur 2, phosphorus 3, silicon 4. Notice all of the halogens form oxyanions that have a charge of -1. All of the polyatomic ions for the halogens will have a charge of -1. And then the charges march inward. They are on the outside, so the ATE version for the halogens has 3 oxygens. That means chlorate is ClO3 with a charge of -1. Bromate is BrO3 with a charge of -1. Iodate is IO3 with a charge of -1. So the charge on the ions on these particular ones match the charge on the polyatomic ions, if that helps you to remember or keep them straight. So the way a series works is we can increase the oxygen content, but it does not change the charge. So the charge on the polyatomic ion is going to be the same. If you have 1 more oxygen on a polyatomic ion, it is called per8. So for example, perchlorate is ClO4, still with the charge of -1. Remember that chlorine is on the outside, so chlorate is ClO3, perchlorate is ClO4. Both of them have a charge of -1. You can also have less oxygens. So the outside ATE versions have 3 oxygens. The inside ATE versions have 4 oxygens. If you reduce that by 1, so for example, let's try carbonate. Carbonate is on the outside, so it would be CO3 -2. Carbonite has 1 less oxygen. The ATE ending is changed to ITE when you have 1 less oxygen. So carbonate is CO2 still with a charge of -2. Sulfite is SO3, still with a charge of -2. If you reduce the oxygen content 1 more time, you put a hypo in front of hypo means we're short of something. So hyponitrite is NO, still with a charge -1. Hypophosphite is 2 less than the ATE version, so PO2 with a charge of -3. So here's how the patterns work. One more than the ATE version is perate, one less is ite, two less is hypoite. So there's a pattern to all of these. Let's find chlorine again, since it's a super common polyatomic ion. Chlorine is an outie, so his ATE version has 3 oxygens. So ClO3 with a charge of -1 is called chlorate. One more would be perchlorate, so that's ClO4 -1. One less is chlorite, so that's ClO2 -1. 2 less is hypochlorite, ClO with a -1 charge. So there's a pattern to all of these polyatomic ions. In your list of polyatomic ions, you can find the set of polyatomic ions, and you can also recognize the pattern. This would be helpful to you if you decided you wanted to memorize these now, or when you get to college and you will be required to know these. There's one other type of polyatomic ion that has an H plus in it. The H plus increases the charge by 1 and adds a bi to the ion. So carbonate is CO3 2-, bicarbonate is HCO3 1-. So let's bring our 3 charts together now. This is the naming the polyatomic ion ins and outs chart right here. Here is a list of polyatomic ions right here. This is a list that you will have reference to this year in chemistry when you're quizzing and testing. And this is the periodic table of the elements. So let's take a look at the separation between metals and nonmetals, which is like such. There's our stair step. So this is our ins and outs chart right here. Remember, I didn't include the noble gases because they do not bond. And then oxygen and fluorine, I'm going to put an X through because they are super electronegative and they're going to be on the tail end and not the beginning of polyatomic ions. So we're talking about polyatomic ions where these are the elements, the nonmetals are the elements in the beginning, and oxygen is the element in the end, and those are called oxyanions. So let's go through the charges. Remember, charges march in -1, -2, -3. All the way across each of these. So those are the charges on every one of the polyatomic ions. Let's go up here and let's find what we call a series. So you can pick any of these elements. So the elements in the beginning of an oxyanion are going to be nitrogen, carbon, boron, chlorine, sulfur, phosphorus, silicon, bromine, selenium, arsenic, iodine, and this guy right here, he doesn't really hang around that much, so we won't talk about him too much. And then in the end is going to be oxygen. So let's find a series of polyatomic ions. How about right here? How about iodine? That is my series right there that starts with iodine. So remember ins and outs. Let's separate our ins and outs. Our outie guys are right here. That's on the outside of the nonmetals. These are the outies. The inside of the nonmetals are these guys right here. So the green guys have 4 oxygens on their ATE version. The yellow guys have 3 oxygens on their ATE version. So let's just do iodine here, right here. We picked him. He is an outie, so his ATE version has 3 oxygens. He is in the first position, so his charge is -1. So IO3 -1 is iodate. Give him 1 more oxygen, and he becomes per-iodate. 1 less oxygen than ATE, he becomes iodite. And 2 less oxygens, he becomes hypoiodite. Hypo always means when you're short something. So hypoglycemic means that you don't have enough sugar. Hypoiodite means that you're short in oxygen. Let's pick an any guy. So an any guy would be like phosphorus here. Because he's an any guy, his ATE version has 4 oxygens. So PO4, let's march the charges in. 1, 2, 3. Is phosphate. 1 more. Remember, the charge stays the same as perphosphate. 1 less is phosphite. And 2 less than the ATE version is hypophosphite. Like such. So that's how you do a series. So this ins and outs chart that I taught you saves you learning 44 polyatomic ions.